Thanks for watching another video from the Memphis Tech, concentrating on technical subjects but made easier to understand. Today we're going to talk about Cisco gear that's located in cabinets, network closets. There's batteries, there's network gear. Industrial and commercial sites usually have special considerations. I'll get into some of those, but not only special tools are needed, but permission to do the work, usually teams to assist with heavy equipment, planning, scheduling communication with managers, and especially with the large equipment that might go down when power is cut, or large monetary assets that are to be considered. This is a little bit about what's inside of a network closet, a main distribution or an intermediate distribution cabinet. Inside these cabinets you have switches. They could have up to 48 ports on an individual, they call them blades or units within the cabinet. At the bottom normally there's a heavy battery in case of brownouts or surges, or if and when you cut over to a generator if there's a power outage. The network gear that connects the rest of the world to a company, more than half the world uses Cisco equipment. They're connected with either various copper cabling or a fiber optic. Normally the racks contain color-coded or labeled ends. It's a very good idea to label the ends when you're installing cabling, because eventually you're going to have to know where the other end of the cable goes. And it's a lot easier to do this when you're installing cable instead of going after the fact and having maybe hundreds of cables that are not labeled. When you're running cable, you normally have an end that's just a bare wire. There's at least two kinds of connector kits or ends, types of ends. Normally there's a simple way to terminate the end, but in my experience, the pass-through modular cable, the wires go straight through the plug, and you can actually see a little bit better that they're going to be in the right position when you crimp the end on the end of the cable. The types that I have here, they look the same. The only difference is one of them this one has a pass-through, whereas the standard type looks the same, but there is no hole for the wire to go through the cable, the cable to go through the end, the connector. Using the pass-through modular plug is a little easier if you don't do it all the time. You're going to get more of them correct. You definitely test the cables, but you'll have better success rate using the pass-through modular plug than one that the wire doesn't actually pass through. What happens is you push the wire in to the non-pass-through type, and you hope that all of them are pushed through about the same amount to crimp properly. It's very hard to see this unless you're testing it after the fact. And I mention this because a lot of people don't talk about the pass-through modular plug. They might be 10 or 20% more expensive, but we're talking about $1 a piece. I don't think that 5 or 10 minutes of time spent uh, with a bad end, or maybe an hour to troubleshoot where a bad end would be, is worth a couple of bucks. Buying the pass-through modular plugs makes a lot more sense. The types of wiring: you can have power going through a network cable called power over Ethernet. The Ethernet is the name of the type of network design, but there's several other things that go into how a cable is made and how it's run. You have shielded and unshielded wire inside the conduit. You have different speeds that the cable is designed to run. So if you're running one computer to a wall jack, or one computer to a switch 100 feet away, it's not as important. A gigabit speed is normally what we go for in that case. However, if you're running a server that 50, 200, thousands of people possibly would be connecting to, you usually have redundant multiple cables, multiple network cards, and higher speed cables. Also, the consideration of where you're running a cable. There is two types of wire inside. One of them is a stranded wire, and the other one is a solid copper. Generally, the solid copper, which is a little bit more rigid, not designed to be flexed back and forth a lot, that's run in walls and to devices that are going to be stationary. Patch cables, short runs that might have a lot of bends to them to get around desks, or plug into a wall jack and run 10, 20 feet at the most. The stranded wire is a lot more flexible inside the conduit. So that's a little difference between what's inside the outer shell of the cable. Also, you have different types of fire considerations. They call this plenum and aerial. So when you're buying cable, a box of 1,000 feet generally isn't too much different price, but if you're buying 10 boxes or 20 boxes, it can add up. So generally, when I buy a box of cable, I buy a Cat 6, Category 6, which is plenty for what I do. I'm only concerned with running about a gigabit speed through it, which is fast, but not the fast speed a server or possibly internet backbone, those types of terminology. You would need something more robust than a gigabit speed through a single cable. Generally, you start running into fiber optics when you get into switches and network gear that's got a lot more throughput to consider. One of the types of equipment, this is the Meraki line that Cisco has. Sometimes this equipment's found not rack mounted. Depends on where you need it and what safety considerations and security is involved. If it's behind a locked door, I've seen this type of equipment not mounted, possibly on a table, or more haphazardly positioned than rack mounted. Sometimes you'll see the and more informal rack, usually a little bit higher out of reach, but maybe not with a door or a lock on it, depending on if it's in a locked room. Sometimes a network closet is just that, a closet. Um, Various times, depending on the equipment, there's no extra consideration for air conditioning. However, when you start getting involved with racks of equipment, there are a lot more considerations for heating and cooling, mainly cooling. For certain rows of equipment might have um, hot and cold aisles, they were referred to, because the heat um, flows through the network closet in an unusual way with all the fans, and every single piece of equipment is a small heater. So you sometimes have redundant air conditioning units, or more than one. In case one of them goes out, you still have another. A lot of times in an industrial area, network equipment is put out of reach, and there's examples of locked doors. Usually those types of equipment don't have special air conditioning in them, in the little cabinets, but they're metal cabinets with glass doors, a little bit of ventilation, and fans to run air through them. They can be up to 15 to 30 feet up. It's very rare that network equipment would be kept where just anybody in an industrial environment could get to it, or also the possibility of damage or even dust and dirt is a little bit different if it's 10 or 20 feet up in the air mounted versus down where somebody might put a Coke on top of it, spill a Coca-Cola, those types of things. So when you get into an industrial warehouse environment, a factory setting, you might wear special equipment like the um, the scissor lift or the telescopic lift with the safety harness, um, hard hats, special consideration for boots, steel toe shoes. One of the reasons that you would wear a safety harness after being trained to do this type of work, um, anytime that you go more than a couple feet up, you start the chance of the safety consideration. Even falling from 5 feet can be very hazardous. Um, the safety training, the special harness, you would actually um, clamp onto the metal rack, the types of things that would be permanent. Um, you first would tie on to, in this case, a scissor lift or a telescopic lift. And then if you were to move any farther out from there, you never reach further than your arm will reach. When you start to lean out towards something, that's getting a little bit more hazardous. So you should follow all the safety considerations. Um, Ladders are not appropriate a lot of times if you have heavy equipment that you're taking out or putting into a network closet or an intermediate distribution frame. They call them IDF cabinets. Those are the ones that might have a key lock. So if the key isn't in the lock, or somewhere, maybe even on top of the cabinet or something, which is common, you're generally not trying to keep a thief out. You're trying to keep it closed so that it could be accessed by special trained network uh, technicians. The scissor lift goes straight up, but where you can't reach straight up to where you want to go, sometimes you have to actually be farther away and have a telescopic way to get to the closet or the cabinet that you're getting the equipment in or out of, or that you're servicing. Um, the reasons that you would have something up in the air would be the monetary value, the industrial conditions you're trying to prevent damage, or just in the ability to, um, you don't need it to get to it frequently, but when you do need to get to it, sometimes depends on what you're doing and how far up it is. You might need various things other than just a ladder. The telescopic lift and the scissor lift, you operate from the actual um, position above. You can roll these things, you can drive them from the um, the spot at the top. You know, you could be up 6 feet and be driving this thing across a flat surface. You start getting into a little bit different um, safety considerations if you have an uneven surface. But we're assuming the places that a semi-specialist or a um, non-specialist heavy equipment operator would only be on a flat surface. As in everything I just said, the first rule is safety. Generally, safety is number one. There is no task that is worth taking a risk. You can learn about these types of equipment online. There's actually some certifications to prove that you've studied and you understand some equipment. Also on site with staff or possibly a more senior person that's more heavily experienced with whatever the equipment is on the job. Um, Printing out and having a copy of the manual, you can get those online. They're very valuable as you or before you using the equipment. Um, Everywhere I've worked, there's different rules and restrictions. Uh, there's always what they call tethering, where you're have the body harness on and you're connected to something. If you fall, you don't fall maybe 1 or 2 feet before this harness holds you in place. It's not designed to feel um, comfortable, but at the same time, when you use these things, it reminds you to be safe, as well as making sure that there is a backup in case something happens. It's common that if, say, you hit your head and you have a hard hat on, but you're still dazed and you slip, that harness is going to help. It's a lot better to fall 1 foot or 2 feet and that harness catch you than anything else. Also, safety glasses. Um, there's 2 or 3 different types of considerations for that. The glasses that you put over prescription glasses, as well as safety glasses that are prescription glasses that have side pieces that are connected to the glasses that keep dust particles out. Um, they're not sealed, but they are fairly tight against your face and they should fit right with all safety gear. A good fit, a tight fit with the body harness. There is no substitute for taking an extra 10-20 minutes to make sure that you're safe. One of the considerations when you're working with network gear in an industrial setting is that you want to continuously have communication and have a backup person, a spotter, if you will. The spotter is going to help. If you're looking one direction, they should be looking the other directions to make sure that everyone around is aware. If there's any consideration, everything comes to a stop, um, so that you can do things safely. Um, the need for speed is totally not part of the safety consideration. Um, when the network may be temporarily suspended because you're cutting the power to equipment, either for safety or to change out a piece of network gear, um, it's a lot easier to work with people in advance and have them schedule the work around the need for possible outages that's planned than to respond at a later time that there's breakage that you're having to um, run somebody to get equipment, to get a certain tool, screwdriver, wrench. Um, Documentation and communication is paramount right after safety. As in network equipment, it's a lot easier to mark the ends of the cables as you're installing. If they're not marked, anytime that you're doing work around this equipment and can identify cabling, it's a lot easier to do that before it's a necessary part of troubleshooting. When you have a network outage, if the cables were labeled, it would be a whole lot easier to get started to find the answer quicker, and also make you look a little bit better, a little bit more, less stress, a little bit more professional. Thank you for watching the Memphis Tech 2020 Vision Technical Video Series. Um, These are technical subjects that I'm trying to make easier to understand. It's my intention not to describe everything in complete detail, because each one of the things I spoke of, you could spend an hour learning about a certain lift, learning about a different type of lift, learning about how to put the ends, the connectors on Ethernet cables, Ethernet wiring, connectorizing fiber optic. There's so many different things. I'm trying to cover things that are a little different than most of the videos that I've seen and most of the training that I've been afforded in my career. I believe there's a lot of times when people um, in the technical field don't understand where people that don't have the experience might need a little bit of information. Um, Once you get that information, then you can learn the specifics of each one of the items that I just mentioned. Anyway, thank you for watching, and please check back for another video trying to make technical subjects easier to understand. I'm Mike, and that's the Memphis Tech video series.